Okay, welcome back everyone. In the last lecture, I tried to make a distinction of the implications of matching in a cohort study versus matching in a case control study. I said the good news is matching in a cohort study with equal numbers of non-exposed being matched to each exposed person avoids confounding. But in a case control study, I made the point that you still have to control for the matching factor in case control studies. So it begs the question, why would you even want to do a matched design when you're doing a case control study? Because either way, you have to control for the factor. If it's a true confounder and you didn't match on it, you're going to have to control for it in the analysis. And if it's a true confounder and you did match on it, from what I just said, you still have to control for it. So what are the real motivations? What are the advantages of matching in case control studies? Because you'll see it happens all the time. Why do people match in case control studies? Well, the real motivation for matching in case control studies is not to avoid confounding alone by just matching. You're still going to have to do an adjusted analysis. But when you do the adjusted analysis, when you've matched by a confounder, you get a more efficient analysis. You have more power for when you do your tests of significance, or your confidence intervals will be narrower when you report your confidence intervals around your odds ratios. So if you don't match on a confounder, you're still going to have to adjust for it. And let's suppose you're going to adjust via stratification like we talked about last week. And what's going to happen, because it's a confounder is related to the outcome. It's an independent risk factor. You're expecting to see varying case control ratios across your strata. What do I mean by that? Let me try to draw something out for you. So let's suppose we're doing a study again with the exposure being smoking. Let's suppose that our outcome, our disease, is coronary heart disease. And let's suppose we're worrying about age as a confounder. And let's suppose, for the sake of an argument, age really is a confounder. Age is in general related to smoking. And age is, say, an independent risk factor for developing heart disease. So let's suppose I did a non-matched analysis. I just enrolled a bunch of cases and a bunch of controls, measured whether they're smokers or not, also recorded their ages, and in the analysis, I looked at the relationship between smoking and CHD stratifying by age. So I have two strata. I have young people and I have old people. Each of these stratas, I'm going to have cases, I'm going to have controls who are young, cases, and controls who are old. And I'm going to be asking them about their previous smoking histories. And I'm going to have 2x2 tables in each of these two groups. One for the young people, one for the old people. So I'm going to have A, B, C, and D. Let me put ones under those. And A, B, C, D. For the old people, I'll put 2 under those to separate the data from the old people, the 2s, from the data from the young people, the 1s. And I'm going to measure odds ratios in each of these tables and use Mantel-Haensel's formula to get the adjusted value, because I'm assuming age is a confounder. So if age really is a risk factor for developing coronary heart disease, then I expect to see a lot of old people among my cases of heart disease. So in my old table, among my cases, I'm going to have lots of people there. But among my young table, among my young cases, I'm going to see few cases there. Now remember, the controls reflect the source population from which these cases came from. And let's suppose the age distribution of that source population is uniformly spread out. There's just as many young people as, say, old people. So among my old table, I'll have some controls there, and I have some of my controls will be in my young table. That's what I'd have if I did not match. But now let's suppose I come along and do another study in the same population where I'm matching. So now imagine doing a study where I match by age. By design, when I enroll a case, if he's old, I find an old control. If I enroll a control and he's young, I find a young control. So when I stratify my data now using my matched study, I'm still going to find lots of old people who are cases. But by design, I'm going to have lots of controls who are old too, the same number, because every case is matched with one control of the same age. In my young table, where I have few cases, I'm going to have few controls also, because again, each of my cases is matched to a control. Well, let's go back to last week when I talked about Mantel-Hansel and talked about information in a table. And what are the determinants of information? I said one thing is the size of the table, the total number of people in the table. Another was the balance between the two groups you're comparing. In a case control study, I'm comparing cases and controls. And notice when you matched in a case control study, you have equal number of cases and controls in the old table and equal number of cases and controls in the young table. You have more information in each of these tables. That's why I mean it's a more efficient design. So going back to the previous slide, matching in a case control study gives me the constant ratio of cases to controls, usually the same number of cases with the same number of controls in each of my tables. That's going to give me a more informative basis within each of these tables to see if the cases are different from controls with respect to the exposure. So as a result, when I do the analysis on the matched data, it's going to be more efficient than if I had done it on the original unmatched data set. And that mathematically is the real motivation for matching in case control studies. People might not appreciate it. They think they might be avoiding confounding by matching in case control studies. In the previous lecture, I tried to demonstrate that doesn't happen. But if you do the matched analysis, after you do the matching, in other words, you still adjust for the matching factor, you're better off in a case control study if you had not matched, as long as that matching factor was a true confounder. Okay, that's what I wanted to talk about, the design implications of matching. In the next section, I'd talk about how we analyze matched data and tie that into what we talked about last week with stratified analysis. See you then.